In early 2025, an AI system in a Nairobi clinic diagnosed a rare cancer, then changed its own diagnosis without human input. When engineers reviewed the logs, they couldn't explain why. No rule was broken, no data changed. It just decided. I was part of that team, and in that moment, I realized GPT-4 isn't the future, it's the foundation. The real power lies in the next wave of agentic systems, intelligent agents that reason, plan, communicate, and act autonomously. I've seen these systems in action, and I'm going to give you the map to understand them, not as abstract concepts, but as real tools shaping our world right now. That moment was a profound shift for me. The chatbots we've all been using, they're just the first step. They're the visible tip of a much, much larger and more powerful iceberg. The true revolution isn't just about generating text anymore. It's about creating systems that can actually act in the world with the kind of autonomy we're just beginning to wrap our heads around. What we saw in that clinic, that wasn't some glitch in the code. It was a preview of the next era of intelligence, a fundamental change in the relationship between us and our machines. My name is Marcel Masaga. I've spent over 20 years building and advising on real-world AI systems, from diagnostic tools in clinics across East Africa to global ethics boards. And through all of that work, my focus has really sharpened to a single critical question. How do we build AI that doesn't just work, but that actually matters? Today, we're going to cut through all the hype to find the answer. We still talk about AI like it's just a language model, but honestly, that's already an outdated view. That's just the starting point. The real power is in what we call agentic systems, these networks of intelligent agents that can collaborate and adapt. To really get this, we're going to need a map. We'll start with the engine, the LLM. Then we'll meet the actor, the AI agent. We'll see how they form teams, or agentic systems, and the critical world they need to operate in. And finally, we'll talk about the most important layers of all, the role of human agency and the brand new ethical frontier we're all standing on. Okay, let's start at the very beginning, with layer 1, the foundation. At the core of every single one of these agentic systems, every tool that feels like magic, you'll find a large language model, or LLM. This is the engine. It's the part that generates the raw material, the text, the code, what you might even call the seeds of thought. Everything that follows is built right on top of this. So what is an LLM really? Well, at its heart, it's an incredibly sophisticated pattern-matching machine. You don't need to be an engineer to get this. Just imagine it's read a library larger than any human could ever hope to consume. The entire internet, millions of books, scientific papers, you name it. Now, from that ocean of text, it hasn't learned facts. It has learned relationships. It's built this massive statistical map of how words tend to follow each other. So when you give it a prompt, it doesn't understand your question the way we do. Instead, it looks at the words you've given it, and it calculates the most probable next word, then the next, and the next, stringing them all together into what is often a brilliant, coherent response. It is, quite simply, a master of completion. And this leads us to the crucial point, the part that gets lost in all the headlines. LLMs are not designed for reasoning. They're designed for plausible-sounding pattern completion. So when it's faced with a new problem or a situation that requires a genuine understanding of cause and effect, it doesn't think, it guesses. Now, it's an incredibly educated guess built on trillions of data points, but it is a guess nonetheless. This makes them amazing tools for brainstorming, for summarizing a long document, for writing a first draft of an email. But when the stakes are high, when truth and accuracy are absolutely non-negotiable, this foundational nature of guessing is a profound liability. And that's why LLMs on their own are no longer the end goal. They are just the base layer. This isn't just some theoretical limit. It has immediate, real-world consequences. At my company, SIHA AI, we build tools for healthcare professionals. We use models like GPT-4 every single day. We use them to generate initial drafts of clinical summaries, to suggest different ways to explain a complex diagnosis to a patient, to help organize messy medical records. But it is never, ever the final decision maker. Why? Because when a person's health is on the line, you need more than just generative fluency. You need absolute certainty. You need accountability. You need a clear, explainable chain of reasoning for every single decision. And those are things a base LLM, by its very design, just cannot provide. It's an indispensable assistant, but it's only the first piece of the puzzle. So, if the LLM is just the engine of thought, how do we get to action? Well, we move to the next layer on our map, the AI agent. This is where we evolve from a passive text generator into an active cognitive partner. This is the leap from simply responding to a prompt to actively pursuing a goal out in the real world. So, what exactly is an AI agent? Think of it like an LLM that's been given a toolkit and a purpose. We take that core language engine and we give it three critical new capabilities. First, memory, which allows it to remember past interactions and actually learn from them. Second, planning, which lets it break down a big, complex goal like organize my business trip into a series of logical steps. And third, and this is the real game changer, the ability to use tools. An agent can be given access to APIs to search the web, interact with your calendar, book a flight, or even run a piece of code. It's no longer just a chatbot, it's an actor on a stage. This slide here really shows the shift in capability perfectly. A standard LLM predicts the next word. An AI agent, on the other hand, decides on the next action. An LLM passively responds to your prompts. An agent actively plans and executes a series of tasks to achieve a goal you've given it. An LLM's entire world is confined to the content it can generate. In agent's world, that extends to any tool it can interact with, your email, your company's database, the whole internet. This is the fundamental difference between a passive oracle and an active assistant. Let's make this concrete. In one of our projects in Kenya, we deployed an AI agent to support community health workers. Now, this agent doesn't just answer medical questions. It actively manages patient care. It takes a doctor's high-level treatment plan and breaks it down into a daily schedule for a patient. It sends out automated medication reminders via SMS, and it's constantly monitoring incoming health data. If a patient's blood pressure spikes, the agent doesn't wait to be asked. It flags the change and immediately escalates it to the human doctor. The crucial point here is that it's not replacing the doctor. It's augmenting them. It handles all the logistical, repetitive tasks, which frees up the doctors to focus on the uniquely human parts of care: empathy, complex diagnoses, and building trust. But with this new power comes a really significant new risk. Because the agent is still built on that LLM foundation, it can still hallucinate. It can still make up facts. The danger is so much greater now because it can act on those hallucinations. An agent could book a flight to the wrong city based on a misinterpretation, or worse, execute a massive financial trade based on a fabricated news report it generated itself. It executes these tasks without a deep causal understanding of the real-world consequences. This is not a trivial problem. It's the central challenge of deploying these agents safely and responsibly. So we don't just deploy them blindly. We build in some non-negotiable guardrails. First, a human must approve any high-stakes action. The agent proposes, the human decides. And this isn't a bottleneck. It's a critical safety circuit. Second, we keep a complete, unchangeable audit trail of every single decision and action. If something goes wrong, we need to be able to reconstruct the why, not just for debugging, but for accountability. Third, we build in robust error handling. The real world is messy. APIs fail. The agent needs to know how to retry or find another way. And finally, agents have to have clear, predefined paths to escalate problems to a human expert when they're out of their depth. The goal is never full, unchecked automation. It's augmented intelligence, with humans firmly in control. So we've gone from a single engine, the LLM, to a single actor, the agent. The next logical step, of course, is to build a team. This is layer 3, Agentic Systems, where the real power of collaboration comes into play. A network of specialized agents can achieve a level of intelligence and robustness that is just far greater than the sum of its parts. It creates a kind of emergent capability. So how do you get agents to act like a coordinated team? Well, you need a few key architectural patterns. You need a protocol for them to communicate with each other, to negotiate and delegate tasks. They need a shared memory, some central knowledge base so that everyone is always on the same page. You can create adaptive teams where a controller agent assembles specialists for a specific task, kind of like a project manager building a team for a new project. And you can have multiple agents collaborate on research, with one searching the web, another digging through internal databases, and a third synthesizing it all into a single cohesive answer. And this right here brilliantly illustrates the concept in practice. In our health tech AI system, we don't rely on a single monolithic doctor agent. That would just be too risky and inefficient. Instead, we have a system. We have a lab analyst agent whose only job is to interpret blood work. We have a medical historian agent that reviews a patient's entire history for relevant patterns. We have a pharmacist agent that checks for potential drug interactions. And then there's a coordinator agent that manages the whole workflow, passing the case from one specialist to the next and compiling all their findings for the human doctor. This isn't just smarter, it's fundamentally safer. Each agent has a limited scope, which reduces the chance of error, and the collaboration provides built-in checks and balances. All right, so we have our team of agents. But where do they operate? What are the rules of the road? This brings us to the final and perhaps the most critical technical layer, the Agentic Ecosystem.
If the agents are the workers and the system is the company they work for, then the ecosystem is the entire city they live in, with its power grid, its laws, and its police force. It's the full stack of infrastructure that enables them to operate safely and at scale. This is the layer that ensures our agents are manageable and accountable. It includes orchestration frameworks to deploy and monitor them, and crucially, it includes a governance layer to programmatically enforce our ethical rules. It provides deep observability and security to prevent manipulation or misuse. And it formalizes those human-in-the-loop controls we talked about, making them a core part of the infrastructure. Without this ecosystem, an agentic system is just a powerful, unaccountable black box. And a black box making autonomous decisions is a recipe for disaster. We've now built our complete technical map, from the LLM engine to the individual agent to the collaborative system to the governing ecosystem. It's an incredible stack of technology. And it's really easy to get lost in the power of what we can now build, which forces us to step back and ask the most important question of all. What is the point? What is the end goal of all this complexity? Where are we actually trying to go with this? And the answer brings us to the most important layer of the map, the one that's not about technology at all. It's the missing piece in so many conversations about AI, human agency. The silent truth, the core principle that has to guide all of this work, is that agentic AI is not here to replace us. It is here to amplify us. The best, the most effective, and the safest agentic systems are not fully autonomous. They are human-led. This is the crucial point. We, the humans, we have to define the vision. We set the goals, the constraints, the ethical boundaries. We validate the outputs, especially in high-stakes domains. And we must always make the final call when judgment and context are required. This human-in-the-loop model isn't some temporary crutch until the technology gets better. It is the only sustainable and responsible path forward, because these systems, for all their intelligence, lack consciousness. They lack wisdom. When a system makes a decision we can't fully audit or explain, we can't fix it with more code. We need wisdom, and that, for the foreseeable future, is still uniquely ours. This brings us to our final layer, the ethical frontier. And I want to frame this not as a problem to be solved, but as an opportunity to be seized, specifically for Africa to lead. The common narrative is always about catching up in AI. I believe that is the wrong frame. We have a chance to leapfrog, not by building bigger models, but by building wiser, more human-centered systems. The dominant mindset from Silicon Valley often focuses on scale, speed, and automation at all costs. The goal is always a smart system. But in many parts of Africa where the concept of Ubuntu, I am because we are, is so deeply ingrained, we can define a different path. Our focus can be on community and equity. Our goal can be human-centered augmentation, not wholesale replacement. We have the opportunity to build systems that are not just smart, but wise. Systems that are optimized for trust, fairness, and long-term well-being. And in a world where trust is becoming the most valuable resource, that focus on integrity is a profound strategic advantage. As we stand on this frontier, we have to be really clear about the true nature of the challenge. The biggest threat isn't what we typically talk about. It's not AI taking our jobs. Humans are adaptable. We've been changing jobs for centuries. The far greater, more existential threat is humans losing our sense of purpose, the erosion of our agency. When we delegate not just tasks but our judgment, we risk becoming passive observers of systems we created but no longer control. That is the real danger we have to guard against. And so we are left with this. The defining question of our time is no longer can we. The engineers, the scientists, the builders, we will almost always find a way to answer yes to that question. The technology will continue to accelerate. The truly important question, the one that requires leadership, not just engineering, is should we? And answering that requires more than code. It requires wisdom. It requires a deep consideration of our shared values. It requires courage to prioritize human well-being over mere technological novelty. That is the challenge and the opportunity for all of us. If you found this valuable, do 3 things. 1, hit like below. It tells YouTube this content matters. 2, subscribe and hit the bell, because next week I'm breaking down the one phase 99% of AI startups skip and how to use it to ship faster. 3, watch my latest explainer, Work in Purpose, From Productivity to Meaning Making. It's already changing how engineers and founders think about AI. I'm Marcel Masaga. Until next time, think deeper, build wiser, lead with courage.